Hey everybody, this is Ms. Fred. This video will help you with your interview test for exact units on the circle. So exact, let's see, values on the unit circle. So I have my unit circle over here. What I don't want to see is the following. If I say, please explain to me how to get sine of pi over 6, and your answer is, hey, Miss Fred, sine of pi over 6 is 1/2. And then you're like, yay, awesome, I'm awesome. Okay, so at that point you have gotten a 1 out of 5. Okay, what you're telling me is I can memorize the unit circle. Again, I want you to understand what and where to find these values. So let me do an example for you. Okay, what is pi over 6? Well, there's a couple things you have to remember. So like really going back a couple weeks ago in the structure of the unit circle. Remember that xy is equivalent, and I've proven it to you, that cosine theta, sine theta. And I didn't, if you notice, I didn't use cosine x on this because we've got an x here, and that's kind of confusing. So that's why we write it different in different places. Okay, so recall that this is the case, right? This is, cosine theta is equivalent to x, and sine theta is equivalent to y. Okay, that's the first thing that you really need to tell me. The next thing you need to tell me is that you know that the radius of this unit circle is 1. Okay, that's why it's called the unit circle, so you know the radius is 1. Now, why is that important? Because that tells us the length and distance of all of these ones here. Okay, can't just go, oh yeah, I know it's 0, the point is 1, 0, because right now, then you have skipped the fact that you know it's 1, 0. Okay, so those are the two things the students forget. All right, the next thing I want you to notice for pi over 6 is you're going to tell me it's in the first quadrant. So we're in quadrant 1. And if you wanted to, that's fine. Or you could even go a little further and tell me, hey, by the way, pi over 6 is 30 degrees. So Ms. Fred, can you go ahead and draw that 30 degrees angle, or pi over 6? And I might even say, okay, tell me when to stop. Go, 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 go. Oh, I think right there, Ms. Fred. Just go ahead and stop there and put a point. Okay, so I would put a point there. And then the next thing you're going to tell me is how to build the triangle. So the next thing is the triangle. So what's that special triangle that you are using? Well, you got to remember the reference area, the reference angle. So the triangle now. Some of you guys were really happy about putting it inside the axes here. So I'm going to move over here. So, oh, keep going, Ms. Fred. Start at 0. Right there. Could you stop right there? Great. Here's that angle pi over 6. And it's not exact, but you know, I know that you know it's in the first quadrant. And then could you go ahead and make me a triangle? So from the point, could you drop down on the x-axis, make a right angle? And since I know this is pi over 6, I know the reference angle is 30 degrees. So you are teaching me as if I didn't know anything. So 30 degrees here. And so that's the reference angle. So what triangle are you using? You are using, and I'm just putting it out here to write it a little neater for you. You are using a 30, 60, 90 triangle. Then you will tell me opposite the 30 is 1. Opposite the 60 angle is the square root of 3 length. And finally, the hypotenuse is 2. Well, I know that sine is, so sine of theta is the same thing as opposite over hypotenuse. Okay? So there is your final answer, which is what I started with, but you can see it's totally different because this shows me all of the elements that you understand. Also, you need to tell me what. So this is, let me go back and label, this is how you got the lengths here. And don't forget, you got to tell me the sign. So the sign value. Put that so you don't get confused. The sign value is positive. Why is it positive? Because this is all students take calculus. That's your little idea that's going to help you. So all functions are positive in the quadrant 1. All right, moving on. Here's another example. So let's say I ask you to evaluate secant of pi. Okay, let's go back and look at all the elements you have to tell me. Okay, again, you know that x comma y is equivalent to cosine of theta and sine of theta. Okay, you also know that the radius is being labeled as 1. Okay, so that you know where these values on the Cartesian plane are coming from. Alrighty, so here's what I want to know about secant. So here by definition, secant is the same equivalency as the reciprocal of cosine of pi. So hey, Miss Fred, can you go ahead and draw me a axis? Why, sure, I can. Okay, student, where is pi? Oh my gosh, there it is. And good vocabulary would be quadrant angle, because there's no triangle for this. Because I might say, hey, do we have a triangle for this? So there is no triangle. So if there is no triangle, you're using the point. And the radius, you've already told me, is 1. So that value for the xy is -1, 0. That explains why the value is -1. Now, it's negative because you're in the second quadrant, and x is negative in the second quadrant. Okay, so now we're going to come over here and evaluate what cosine is. Well, remember what you told me up here? This is true. So x is cosine. So that means this is 1 over -1. So you just simplify that and we get -1. So you can see the sign falls straight out with that one. The main thing is you tell me there's no triangle, we've got a quadrant angle, and you're using the point and the definition. Okay, you got to make sure you understand that definition. Okay, let's move on to the next one. Okay, we're going to transition over to tangent. So this is number 3. Let's do tangent of 2 pi over 3. All right, so one thing you need to keep in mind are what are those reference angles? So pi over 3, if you convert it, is 60 degrees, or you remember from previous lessons. So if you know it's 60 degrees, just to give you an idea of what you're doing, this is 60 degrees and you're multiplying by 2. So this is really the same thing as tangent of 120. Now, why is that helpful to you? Because it tells you where the angle lies. Because you're going to tell me to stop right about there. So this is about 2 pi over 3. Okay, and that's at 120 degrees. Okay, so we have that. And now you're going to tell me what the reference angle and all that fun stuff is. But you got to also remind me that xy is also the same thing as cosine and sine. You're going to tell me the radius is 1. Why? Because we assigned it, okay? Because if I say, hey, why is the radius 1? You're going to say because we labeled that ourselves. We picked it. Okay, so once we have that, you're going to get me the reference angle. So let me clean this up a little bit for you. Okay, the reference angle you already know is going to be 60 degrees, but I will draw it out for you. Okay, so 120, what's left over is right here. You know that this is 60 degrees, so this is your triangle. And since it's neat, I can go ahead and put the values in here. Okay, across 30 degrees is 1, but it's negative because we're on the negative part of the axis. This is square root of 3, it's positive, and the hypotenuse is always positive. All right, so I've got my reference angle, I've got my special triangle, so this one does have a triangle. And then, so I better star these for you so I know that you know what's going on. Okay, so now we're going to look at the definition, and then we're going to calculate. So what's the definition? The definition for tangent, again, you know, I'm just reminding you because you got to know when to flip from one to the other. Okay, so this is the same thing as sine x over cosine x, but it's also the same thing as opposite over adjacent. And that's what we're going to use this time because we've got our special triangle. So I've got 60 degrees. So opposite of 2 pi over 3. So opposite is the square root of 3. And then opposite over adjacent is -1. Okay, so and then I'll say, oh yeah, that's cool. How come why is tangent negative in this quadrant 2? And then you can always go back to what's positive. You can just do it, the counter example, which is you tell me, oh, you know what? Sine is the only function and its reciprocal is the only function that's positive in the second quadrant. Thus tangent has to be negative. So tangent must be negative in the what? In the second quadrant, because that's where the angle is. So I'm just going to simplify this so it's negative square root of 3. All right, I'm going to do one more. I think I will do cotangent for you. And then at this point, you've done examples in class. If you have any additional questions, you need to ask me in class. So I'll do one more. Okay. All right, this time I'm gonna do, let's do secant of 5. Well, no, we haven't done any pi over 4s. So let's do 7 pi over 4 for this one. Okay, remember, pi over 4 is the same thing as 45 degrees. So what do you really have is 7 times 45. You know, you can use your calculator, you can use notes, all that stuff. Just get yourself organized. And so that's about, or it is, the same thing as secant of 315 degrees. So where's that angle? It's over here. Or again, you don't have to convert it to degrees. I don't care about that. I care about what quadrant are you in. What's the quadrant? Because then you got to tell me how to draw that. So this is 7 pi over 4. Ooh, that line is really crooked. Okay, so this is 7 pi over 4. So this is just helping you where to locate it in what quadrant. Okay, so again, you're going to tell me that xy you know is equivalent to cosine sine. Okay, Ms. Fred, the radius, I'm making 1. Okay, what's the next thing I need? I need the reference angle, if I have one, right? Because if it is a quadrant angle, you have no triangle. So the reference angle is right here. And you need to draw the triangle down to the point perpendicular to the x-axis. Okay, so this is 45 degrees. You already know that because the denominator is 4. The reference angle is 45 degrees, which means you have a 45 degree triangle. Okay, so now you can explain to me the special triangle that lives inside here. And so that is, let's see, 1, 1, and the square root of 2. But this guy right here, because the y's are negative, is -1. Okay, so what is the definition for secant? Secant of x is the same thing as 1 over cosine of x. Okay, so you're really going to tell me what cosine of x is. So this would be opposite over hypotenuse. No, just kidding, guys. Adjacent over hypotenuse. So adjacent over hypotenuse. So what do we got here? So cosine of x is adjacent, which is 1 over the square root of 2. How did I catch myself? I knew that cosine had to be positive in the fourth quadrant. Now you can go ahead and rationalize this. That's great, okay? But the form it's in, it actually creates a shortcut for us. So it's not wrong if you go, oh, you know what? By the way, if you rationalize that, you get the square root of 2 over 2. That's fine. The main thing you need to understand is that when you flip the fraction around, you get the reciprocal, which is secant, and the sign value, which is kind of really the last thing. You are positive in the fourth quadrant for cosine is positive in quadrant 4. Thus, secant also has to be positive in quadrant 4. Okay, there you go. That should give you enough to understand what you need to do for me, and I will talk to you later.